All right, let's talk about one of the trickiest parts of SPM chemistry, chemical formulas and equations. If you've ever felt a bit lost, don't worry. In this explainer, we're going to give you the complete playbook to absolutely master these concepts. Let's get into it.
Okay, so before we jump in, just a quick reminder. The best way to make all this stuff stick is to actually practice it. You can do that with real exam-style questions over at mcqspm.com or just grab the MCQ's SPM app. Seriously, it's a game changer.
Look, if you've ever stared at a formula full of letters and numbers and just felt your brain shut down, trust me, you are not alone. But I've got a secret for you. There's a code to it. And today, we're going to crack that code together.
So here's our game plan. First, we'll decode what those formulas actually mean. Then we'll look at lab setups, move on to the art of balancing equations, and finally, we'll conquer those mole calculations. Let's get started with section 1. First up, we're going to clear up something that trips up so many students: the difference between an empirical and a molecular formula. Getting this right is absolutely fundamental. Now, you are definitely going to see this on your exam. It might look like just a simple definition, but if you don't really get what it means, a whole bunch of other problems become impossible. So let's lock this down.
Okay, here's the number one mistake I see students make. They mix these two up constantly. So think of it like this, right? The empirical formula, that's your basic recipe. It's the simplest ratio of ingredients. But the molecular formula, that's the actual final dish, the total number of ingredients you used. Simple as that. And glucose is the perfect example. You'll see it all the time. Its simplest ratio, the empirical formula, is CH2O. That's a 1:2 ratio. But the actual molecule, the final dish, is C6H12O6. You can see if you just divide everything in the molecular formula by 6, you get right back to that simple CH2O recipe.
Okay, let's do one together. This is a classic exam question. Don't let it scare you. It's just 3 easy steps. Step 1, find the mass of your basic recipe, our empirical formula. So CH2 is 12 plus 2, which is 14. Step 2, find your multiplier. How many recipes fit into the final dish? Just divide the total mass, 56, by our recipe's mass, 14, and that gives us 4. And finally, step 3, just multiply your recipe by 4. So CH2 times 4, bam, you get C4H8. You've got your answer.
All right, theory's down. Let's get practical. We're moving on to interpreting lab diagrams. You're guaranteed to see these on your exam, so let's make sure you can read them like a total pro.
When you see a diagram like this, don't just stop at naming the crucible and the Bunsen burner. The real marks, the high marks, come from understanding why you're doing what you're doing. What's the point of each step?
So think about it. These aren't just random instructions a teacher made up. Examiners love to ask about these steps because they test if you really understand the experiment. And here's the secret. It's all about accuracy. You lift the lid for a second to let oxygen in so the magnesium can react, but you close it fast so you don't lose any of your product, that white magnesium oxide smoke. And you heat until the mass stops changing to be absolutely certain that every last bit of magnesium has reacted. It's all about getting perfect data.
Okay, next up is a skill that honestly feels like a superpower once you nail it: balancing chemical equations. Think of it like a perfectly balanced scale. You can't just have atoms appearing out of nowhere or disappearing into thin air. That's a fundamental law of the universe. So whatever atoms you start with on the left side, you have to end up with the exact same number on the right. And here's my absolute favorite pro tip to make sure you never make a silly mistake again: use an atom scorecard. Just make a simple table and count them up. On the left, we've got 2 coppers, 4 nitrogens, and 12 oxygens. Now let's check the right side. Yep. 2 coppers, 4 nitrogens, and 2 plus 8 plus 2 is 12 oxygens, perfectly balanced. This little trick makes it almost impossible to get wrong. Okay, deep breaths, everyone. We're heading into the big one: mole calculations. I know, this is where people get nervous, but trust me, we're going to break this down and make it super simple. Now here it is, the number one trap that almost everyone falls into at first. They see 9.75 grams and 63.5 grams, and they immediately try to compare those numbers. No. You have to remember, chemistry doesn't speak in grams, it speaks in moles. Moles are like the currency of chemistry. It's all about the number of atoms. So just follow this 3-step playbook every single time, and you cannot go wrong. Step 1, convert that mass into moles using the RAM. Step 2, find the simplest ratio. How?
Just divide both mole numbers by whichever one is smaller. Here, that gives us a clean 1:2 ratio. And finally, step 3, just write the formula. It's XY2. See, that's all there is to it.
Phew, we have covered a ton of ground. So let's boil it all down into the core strategies, your final pro tips for exam day.
This is it, your exam day cheat sheet. Burn these 4 points into your brain. Empirical is the simple recipe. Molecular is the actual count. For lab diagrams, always ask why. Use that atom scorecard to balance equations. And the most important one, for any calculation, your first step is always convert mass to moles.
And that's a wrap. You now have the complete playbook. All that's left is to practice. So head over to MCQSPM.com, try out some real exam questions, and build that confidence. You've totally got this.